Today we're going to solve logarithmic equations. Solve the following logarithmic equations. Give it a try and play the video whenever you're ready for the solutions. Question number 1. Log of 10 minus 4x equals log of 10 minus 3x. For both sides to be equal, the value of 10 minus 4x must be equal to 10 minus 3x. Isolating the variable x on one side, we need to add 4x to both sides. So left side becomes 10, right side is 10 plus x. Subtracting 10 to both sides, 10 minus 10 is 0, and the right side is x. So for number 1, x is equal to 0. If we plug in x is 0, 10 minus 4x is positive, 10 minus 3x is also positive. So x equals 0 is not an extraneous solution. Question number 2. Log base 12 of v squared plus 35 equals log base 12 of negative 12v minus 1. For both sides to be equal, the value of v squared plus 35 must be equal to negative 12v minus 1. Writing this in standard quadratic equation, we need to add 12v and plus 1 to both sides. And we will have v squared plus 12v plus 36 is equal to 0. This is a perfect square trinomial, so we can factor this as v plus 6 times v plus 6 equals 0, or the same thing as v plus 6 to the second power. Setting each factor equal to 0, we will have v plus 6 equals 0. There is no need to write another v plus 6 equals 0 because you will have the same answer anyway. Doing inverse operations, our v value is equal to negative 6. Checking for extraneous solutions, let's plug in negative 6. If we plug in negative 6 to the v squared plus 35, that's positive. Negative 12v minus 1 will also be positive. So v equals negative 6 is our solution for problem number 2. Question number 3. ln n squared plus 12 is equal to ln negative 9n minus 2. For both sides to be equal, the value of n squared plus 12 must be equal to negative 9n minus 2. Writing this in standard quadratic equation, we need to add 9n and plus 2 to both sides. And we will have n squared plus 9n plus 14 is equal to 0. By factoring, we need to find factors of 14 that will give us a sum of 9. What do you think are the two numbers that multiply to 14 and add up to 9? 7 and 2. 7 times 2 is 14. 7 plus 2 is 9. So the factors are n plus 7 and n plus 2 is equal to 0. Setting each factor to 0, we have n plus 7 equals 0 and n plus 2 equals 0. Doing inverse operations, we need to subtract 7 to both sides, and we will have n equals negative 7. For the second, we need to subtract 2 to both sides, so n is equal to negative 2. Now we need to plug in negative 7 and negative 2 to see if there's any extraneous solutions. If we plug in negative 7 to the n squared plus 12, that's positive. Plugging in negative 7 to negative 9 and minus 2, that's also positive. So n equals negative 7 is not an extraneous solution. Now let's check negative 2. Plugging in negative 2, n squared plus 12 will be positive. Negative 9 and minus 2 will also be positive. So n equals negative 2 is not an extraneous solution. So number 3 has two answers. N equals negative 7 and n equals negative 2. Solve the following logarithmic equations. Give it a try and play the video whenever you're ready for the solutions. Question number 4. Log of 4k minus 5 equals log of 2k minus 1. For both sides to be equal, the value of 4k minus 5 must be equal to 2k minus 1. Solving for k, we need to subtract 2k to both sides, and we will have 2k minus 5 is equal to negative 1. Adding 5 to both sides, we will have 2k is equal to positive 4. Now, dividing both sides by 2, our k value is equal to 2. Now, let's check for extraneous solution. If we plug in k is 2, 4k minus 5 is positive, 2k minus 1 is also positive. So k equals 2 is a solution because it's not an extraneous solution. Question 5. Log base 9 of negative 11x plus 2 equals log base 9 of x squared plus 30. For both sides to be equal, the value of negative 11x plus 2 must be equal to x squared plus 30. Writing this in a standard quadratic equation, we need to add 11x and subtract 2 to both sides. So we will have 0 is equal to x squared plus 11x plus 28. Now we need to factor out this quadratic equation. We need to find factors of 28 that will give us a sum of 11. What do you think are the two numbers that multiply to 28 and add up to 11? 7 and 4. 7 times 4 is 28, and 7 plus 4 is 11. So the factors are x plus 7 and x plus 4. Writing each factor equal to 0, we will have x plus 7 equals 0, and x plus 4 equals 0. Doing the inverse operations, our x values are negative 7 and negative 4. Now let's check for extraneous solutions. Plugging in negative 7, negative 11x plus 2 will be positive. X squared plus 30 will also be positive. So x equals negative 7 is a solution. Now let's plug in negative 4. If we plug in negative 4, negative 11x plus 2 is also positive. X squared plus 30 is also positive. So x equals negative 4 is another solution. So for number 5, the answers are negative 7 and negative 4. Question number 6. Log of 16 plus 2b is equal to log of b squared minus 4b. For both sides to be equal, the value of 16 plus 2b must be equal to b squared minus 4b. Writing this in standard quadratic equation, we need to subtract 16 and subtract 2b to both sides. So we will have 0 is equal to b squared minus 6b minus 16. Factoring this quadratic equation, we need to find factors of negative 16 that will give us a sum of negative 6. What do you think are the two numbers that multiply to negative 16 and add up to negative 6? Negative 8 and positive 2. Negative 8 times 2 is negative 16. Negative 8 plus 2 is negative 6. So the factors are b minus 8 and b plus 2 is equal to 0. Setting each factor equal to 0, we will have b minus 8 equals 0 and b plus 2 equals 0. Doing the inverse operations, our b values are 8 and negative 2. Checking for extraneous solutions, let's plug in 8. If we plug in 8, 16 plus 2b is positive. B squared minus 4b is also positive. So b equals 8 is not an extraneous solution. Now let's check for negative 2. If we plug in negative 2, 16 plus 2b is positive. B squared minus 4b will also be positive. So b equals negative 2 is not an extraneous solution. So the answers for number 6 are positive 8 and negative 2. Thank you for watching. And please consider subscribing to my channel at Celzo Academy.